Okay, I'm probably going to start right now. It's already 15. So I'm going to talk about malicious browser extensions, and especially what kind of protection are in there in web browser and how we can bypass them. So just a few words about me. My name is Julien Sobrier. I work at Zscaler. We mostly focus on web research, web security research. You can go to our blog at research.zscaler.com. And we also have a few free tools at threadlabs.com, including browser extensions. So why is this talk? I've been working on browser extensions for about 2 years, making security extension to protect users. But while I was doing this, I realized that browser extensions are a lot more powerful than I expected. And while I was making user more secure, you can actually do a lot of very bad things with browser extensions. So this is what I'm going to talk about today. So first I'll talk about browser extension in general, and then I'll go deeper in each of the three major web browsers to see especially how the plugin architecture works, what kind of protection they have, and what kind of malicious extension you can do on these three browsers. I probably will not have enough time to talk about Chrome, but we'll see if time permits. So browser extension, they don't feel like regular software. Most people I talk about, it's like extension for any software. They feel like it's just add a few features. They are not as scary as install as an installer. You don't have any warning. It just feels like a very simple piece of software that has a very limited role on your computer, and it's easy to remove. It shouldn't be very harmful, and that's actually very wrong. And I'm going to explain why. So first, what are browser extensions? So in Firefox and Firefox Mobile, Firefox extensions are mostly JavaScript files. They have an interface called XPCOM that allows Firefox plugins to use more advanced features like zipping, unzipping, accessing the file system in JavaScript through these XPCOM services. And in Firefox, an extension has access to the entire browser, including the content of each tab. Chrome and also Safari and Opera is a little bit different, so it's still using JavaScript for all the for the extension, but the extension is split into two parts. One is the background page, which has access to the browser, but not to the content of the tab. And the other part is the injected script that's injected into the tab and which has access to the tab but not to the browser. And the two can talk to each other. Extensions don't have full access to the web browser, and they are isolated from each other. And again, I'll go into more details when I talk about each of the different web browsers. Internet Explorer is a completely different beast. It's actually compiled code, either .NET or C++, and the browser extension is loaded for each tab. So what can you do with these browser extensions? So for all the browsers, you can access all the cookies that are being transmitted or that have already been stored by the user from previous sessions. You can see all the password and login that are sent, and because you are inside the web browser, it doesn't matter if you're using HTTP or HTTPS. But for Firefox and also Internet Explorer, you actually have access to the entire file system. You can read anywhere on the file system, and you can run executables. There are some limitations for Internet Explorer that I'll explain later. And Firefox, which is the browser with the most powerful plugin architecture, you can also write anywhere on the web browser. Extensions can also replace part of the web browser. And they have access to all your login and password that you may have saved in the web browser. When you enter a login password, they usually ask you if you want to save it. So, what do you need if you want to write a web malware? So you want to extract all the useful information from the from the user. So you want his credentials so you can get access to his account. You want to be able to send these credentials out to your own server. You want maybe to steal some of the important document if it is a corporate computer. Any kind of information about the user, like social security number, credit card. Then you want to try to use the information about the user to spam other users or to contact other users. So you might want to have access to his email contact, his Facebook friends, LinkedIn, etc. You might also want to change web pages, trusted web pages. So if somebody is going to make payments through PayPal, for example, you might want to change who is actually getting the money. You might want to change some of the links so that instead of downloading a software from a known website, you can actually download a malicious executable from anywhere else. You might want to send spam, and you want to do that being invisible, right? You don't want the user to notice that you're actually doing all of this on his computer, and you don't want antivirus to catch you and block you. And if you look at what browser extension can do, that's actually all of this. And I explain why. But you can access all the user credentials because everything that we enter is 99% through a web browser when you log into your bank account, etc. Because you're on the web browser, you can of course make HTTP requests. So once you have access to this credential, you can send them out. I mentioned that on Firefox and Internet Explorer, you have full access to the file system, so you can read any document and upload them. Any important information like social security number that are entered on any web form, you can also access them. And again, because you are inside the browser, you have no problem modifying the page or accessing any of the data like Gmail contacts. So what protection do the user have on their computer? Well, if you're outside of a company, that pretty much the only security tool that people are running is their antivirus, which does two types of detection mostly, right? One is behavior analysis, trying to figure out that some piece of software is not behaving normally and has a suspicious behavior, and static analysis. It doesn't work very well for browser extension. Every time I upload a browser extension to VirusTotal, I usually get this kind of result. No AV vendor is able to tell that a browser extension is actually malicious. And why? Why is it? So if you look at behavior analysis, what an AV would look at is a process that's hooking into other processes. So for example, Keylogger might hook into some application or your Windows system to intercept all the keyboard information. A process might try to connect to internet. You may have seen, for example, even when you install Skype, Windows might ask you if you want this software to connect to the internet. It will probably add itself as a service or to the startup to make sure it's running every time you restart your computer. And then it might be trying to hide itself, and it might try to access part of the file system that's not expected. But if you are inside of the browser can do all of this action, right? The extension is not visible to the operating system because it's not a separate thread. It's actually inside the web browser. Web browser does need to have internet access, so there's nothing wrong with that. Browser is always running, where we all surf the web all the time. And and the browser needs to have access to the file system, right? When you're opening file or sending file. Sorry. Okay. So because there's no distinction between the browser extension and the web browser, you cannot tell that who is sending the HTTP request. Is it the web browser or is it the extension? Who is accessing a file on the system? Is it a particular browser extension or is it the web browser? So behavior analysis is useless. Then you have static analysis, basically signature. And It works pretty well with Internet Explorer. Usually when I upload malicious DLL for Internet Explorer, they are found to be malicious by at least a few vendors. But for Chrome and Firefox, pretty much never. And there's there are a couple of reasons that I'll show a little bit later. But one of them is the way extensions are handled by the web browser. So let's see in Firefox, and don't hesitate to ask questions if something is not clear, or if you need any more details. So a little bit more details about extension in Firefox. So Firefox-Extension are distributed as a .xpi file, which is just a zip file with different extensions. And among all the files that make up an extension, there are three very important files. One is called install.rdf, which describes the extension to Firefox. And one of the important information is the ID. Each browser extension has to have a unique ID that's provided by the extension creator. So usually it's a GUI ID or an email. Update URL, where does Firefox go to check if there is a new version available for this add-on, and the current version of the add-on. So this is what the install.rdf looks like. You can see under description you have the ID here, the GUI ID, you have the version number here, and you have the update URL here. So install.rdf, you have the one JavaScript file, at least, that actually contains your code for the extension. And the third file that you need is called an overlay, and that basically ties the JavaScript file with your web browser. So this is an example here of an overlay that ties your JavaScript file. So this is a JavaScript file that contains the code of the extension, and it ties it to the web browser. And you can also add other stuff. So, like, for example, there is a status bar that's added to the web browser. You can actually add native code to use your own native code inside the Firefox extension. You can embed C++ library, and you can also the extension here can also replace a part of the browser. So most of the browser parts have a GUI ID. So, for example, the pop-up blocker has its own GUI ID, and you can declare your own pop-up blocker, for example, to replace part of the web browser. So, as far as updates, so I mentioned the update URL. That's what Firefox uses to figure out where to go to check if a new update is available. There could be an update key. If you do update over HTTP, you are required to have an update key to sign the update manifest. But that's really a big pain. So usually people just use HTTPS, and then you don't need to sign anything. And when Mozilla Firefox drops the update manifest, it will look for the ID and see if the version number is higher, and then it will download everything. It's a little bit different if you download the extension from the Mozilla add-on website. There's no update URL. Instead, they use system settings, and they just use the same URL with a different ID to figure out where to look for the update. So what I've not mentioned, and that's not found in Firefox extension, is there's no permissions. So extension has access to everything. There's no limitation on what they can do. It doesn't declare if they have access to the file system or if they have access to HTTPS website. And the extension itself is not signed. It's just, in some cases, the update manifest might be signed, but the extension is not signed. So Firefox cannot tell if an extension is modified at any time. Okay, so now that I've described how it works, let's see what we can actually do in Firefox with a malicious extension. So I mentioned that you have access to the full browser. You also have access to the setting of the web browser. So what you could do, for example, is start disabling the security feature of Firefox. Firefox uses Google Safe Browsing as a blacklist. So what you could do is just change the setting to disable this feed. But it's not really stealth, like my title mentioned in the talk, because if you go to the option, if the user actually bothered to go, to do a few clicks and to go into the option under security, you will see that the blacklists are now unchecked because you just disabled it through the settings. So what you can do to be silent instead is, and that's something that can be done for many features, is instead of disabling the feature, disable the data that the feature is using. So if you Google Safe Browsing has to be updated every 30 minutes. So what you can do is simply change the URL it's using to be nothing. So now Google Safe Browsing cannot update itself. And if you want to remove what was there, there's a database, SQLite database, that you can just empty. It's a regular SQLite 3 database. We can just issue one statement and remove what's over there. So now, if you go through the UI, you won't notice anything wrong. I mean, the two checkboxes for Google Safe Browsing are enabled, but Google Safe Browsing is not able to get any data, and you won't get any warning. And because all the browser extensions settings are stored at the same place, you can also start disabling other security features. So for example, the BDQ scan is AV extension. What you can tell is, every second you just tell the extension that it just ran a scan, so there's no need to do another one. Or this is a extension I wrote called this killer safe shopping that gets downloads regularly a list of malicious fake online stores. Again, you can just change the URL, and now the plugin is not able to get any new information. So you can pretty much disable all the features, all the security features of the web browser and the extensions, and the user won't notice anything. And once you've started infected the user's browser, what you can do also is stop updates for the web browser. So you might fear that some new update of Firefox might have improved security and might detect what you're doing. Again, just change the URL that Firefox uses to look for updates, and it won't be able to find updates automatically. So I said that you have access to the whole file system for reading and writing. So you can also infect existing extensions. So if you're afraid that users might remove your malicious extension at some point, then you can start adding your own code into the existing extensions. Because extensions are not signed, so Firefox won't be able to tell that the version is running is a modified version from the one that was installed. And then you have two options. Once you have infected the existing browser extension, you can either infect the extension that are on the file system and disable all the updates, or you can do the opposite. You can force Firefox to update the current extension to malicious versions. And to do that, you simply have to change the update URL in the install.rdf and change it to your own URL and force an update of the extensions, for example, by setting a small update interval. And now Firefox will actually do the infection for yourself. It will try to find an update, find one because you have one already, and replace the good extension with a malicious one. Or you can, from your extension, modify the code of the other extensions, and then you want to make sure that Firefox does not update the infection that you just infected, and you can do the same kind of trick. So you can disable completely extension update. You can modify the update interval to be very long. You can override the update.url information in the file, so it points to a wrong URL. Or you can change the update URL for the extension that are downloaded from the official store. Or you can just have a huge version number. version number 100, and no update will be valid because they will always be lower. So besides extension, then you can go even deeper and actually start replacing part of your web browser. So a lot of the Firefox code base is actually JavaScript. There's a file called omni.jar. You can look on your Windows or Linux Mac computer, and it's just a zip file. And if you decompress, you will see that there are a lot of JavaScript files that define, for example, the pop-up blocker, or how a tab looks like, or what kind of information that might be added to a tab. And you can start replacing that. So you can, add your own malicious code to every tab just by modifying the browser itself. And then again, disable browser updates so the user never get a good version anymore. You can also add and remove file. So you can use the browser extension just as a file dropper to again get internet access without being visible because the browser has internet access, and just drop a malicious file on your computer and execute them. So extension can do a lot of bad stuff, but how do you actually get the users to install this extension on their computer? So you have two ways to install an extension in Firefox. The one that is usually used is you click on a link that points to an extension. Firefox presents a first warning as telling you that the website wants to install an extension, so you can allow or deny. Then you get 5 seconds to actually think about it carefully, and then you can click install. So there's no possibility of silent installation from the web. So if you want the user to install a malicious extension from your website, you have to use some social engineering. So what you usually use is like a fake flash update. You go to a website, tells you want you to see this video, but you have an old flash version. So please download this new flash version, and then you get prompted for an extension that looks like a flash update. Same thing with fake video player. One of the nice things of using browser extension and not not just a regular file download that the user should download and install is first it's only one click, so you don't have to the user doesn't have to download and then install. And also browser extensions that are downloaded don't go through the download manager, and you probably notice that every time you download the files through Firefox, before you can actually click on it, the antivirus run if you have one installed. If it's a known malicious file, the AV will block it before you can actually click to execute it. But with browser extension, they're handled automatically by the web browser, and there's no opportunity for the AV to kick in. And the other good thing, and I've seen that a couple of times, is you don't actually have to put the malicious content inside the extension. The extension can pull its content after it executes. So there's nothing very early malicious in the extension that you're downloading. It's just when it runs, it will download the malicious code and then run it. So the AV won't detect that it's a rogue extension. And AV in general is very bad at detecting threats in text file. So I tried, for example, one known piece of malware from the black hole exploit kit. I took something that was not too old, not too new, so that all AV had time to actually see it, and only half of the vendors can actually find something malicious in this JavaScript file. When I run the same thing for the executable that are downloaded by the black hole exploit kit, the success rate by AV vendor is much higher. Another thing that is in favor of browser extension is a lot of antivirus don't scan .txt file by default. The thing is, yes, the extension doesn't mean anything for Firefox. I mean, the JavaScript file can be can have a .txt extension, can have any kind of extension. So just rename all your JavaScript file as .txt, and most of the AV won't bother looking at them. Now, there's a second way of doing extension installation on Firefox. It's called a third-party installation. So if you came across one of these repackaged VLC or repackaged free software that's trying to install like a toolbar, for example, on your web browser, this one, Elevate, is one I see all the time these days. The way they work to install the application is actually drop the extension into your Firefox profile. So next time you run Firefox, Firefox will see the extension. And in recent before it used to be silent, like in the Firefox 3.x, third party could add add-ons to your profile, and it will just be used right away when Firefox started. So they've made some improvements to combat this third-party rogue extension, but the protections they have are very easily bypassed. So one of the protections they have is a list of blacklisted extension. They have an XML file in the user profile that contains a list of browser extension IDs that are known to be malicious, and this list is updated automatically. But again, because you have full access to the browser settings, when you install an extension, you can always disable this block list. And if you do a third-party installation, you can also remove the file that's inside the user's profile before you install your own application. And the file is just a list of IDE. I mean, every time you download the same add-on, you could generate a new GUI ID, for example. So all your malicious add-on will always have a different GUI ID, and Firefox wouldn't be able to keep up anyway. So the other protection they added is now when you restart your web browser after third-party installation, Firefox will actually prompt you and tell you, hey, there's a new add-on here. Do you actually want to enable it? And by default, it won't be enabled. So users are aware of new extension being installed that way. But again, it's actually very easy to bypass. So Firefox stores all the information about extensions that are already installed into a database, again SQLite 3 database, so very easy to access. So what you can do is simply add your own record into the table. It's very simple. I actually had the demo ready for that, but I probably won't have time. So when you do your third-party installation, just add your add-on into this database. Say, hey, this is an extension that was already installed 2 weeks ago. Don't worry about it. And when the user starts the browser, it doesn't notice that there is a new extension because Firefox won't prompt the user. The extension will be running. So very, very easy to bypass. Yeah, I probably won't have time for that. Maybe we'll see at the end of the talk. Any question about Firefox or no? Okay. So let's see Chrome. Chrome is a much newer browser, and for a long time, actually quite a weak browser architecture. Like up until maybe 2 years ago, you couldn't do very interesting things with it. But also, I mean, it has much more robust security system. So Chrome extension also made up of 3 main files. One is a manifest file, which is similar to the install.rdf for Firefox. It describes the extension, so like the name, version, and you do have permissions inside the file that are shown to the users. So I can show one example here. So you have to say, for example, if you want to inject a script here, in which type of pages you want to have access. So here means any HTTPS website. If you want to use some special API that can modify requests, for example, or look at that are a little bit risky, you also need to request permission for that. Then you have a background page that has access to the web browser, but not the tab, and the injected file that's injected into the tab and that has access to the tab content, but not the browser. And the two can communicate to each other. So much more isolation. Each extension is completely independent from the other. They cannot share settings. They cannot talk to each other. Extension cannot change any setting for the whole browser, only its own own settings. It doesn't have access to the file system. It cannot run or include any native code. They've added it to Chrome OS, but not to Chrome. And like I said, if there is any risky access that you need to request it in your manifest file, so the user know what the add-on has access to. So the attack surface is much smaller for Chrome. And in the latest version, I think it's Chrome 20, if I remember correctly, you can only install extension from their own store. Third party. So this is when you download an add-on from their Chrome store. That's the kind of pop-up that you get. You see the permissions here. You have a chance to cancel if you change your mind. And now if you try to download an add-on from a different website, you will get this warning that tells you that you can only download it from the Chrome web store only. If you really want to install a third-party, an extension from a third-party website, you actually have to download it as a regular file, go to your preference, to the extension page, do a drag and drop, or you have to run Chrome with a special parameter to allow a third-party website. So that means a lot less options to get users to install a malicious app. Now you actually have to trick Google into accepting your malicious site extension on their website. So the only way to compromise extension is really to modify the JavaScript file that's on the file through a third-party executable. Again, the extensions are not signed, so Google Chrome is not aware of any change. And next time you restart Chrome, you will pick up the code changes, and you'll be able to leak data like your session cookies, your username, password. But so it's more limited architecture, less options, no access to the file system, no way to run executables, more secure in general. Okay, now probably the most interesting, Internet Explorer. So browser extension in Internet Explorer are called the Browser Helper Object, BHO. If you Google for BHO, probably the first 30 results will be about malware that were installed through BHO. So browser extension on the Internet Explorer have a very bad reputation. So there are compiled codes, there are DLL, that can be done either in C++, or .NET. And it's a complete black box when you download the DLL. You have no way of knowing what it's going to do. It doesn't even export any function. So you really can't tell what it's doing. There's no permission, nothing like that. And browser extensions are handled completely outside of the web browser. So you cannot download on a link, and Internet Explorer will not handle the installation for yourself. And one thing that's also a little bit weird about Internet Explorer is that if you want to create a toolbar, if you want to create like menu options and your own extension, they have to be separated BHO. So in Firefox and Chrome, you typically have at least two screens. One is the option screen, maybe a pop-up next to your URL bar, and your main code, and that will be in the same extension. But for Internet Explorer, you have to do 3 different browser extensions for that. So let's see how you. Main protection of Internet Explorer is called protected mode. You're probably aware of it. That means Internet Explorer and all its extensions are running as a low integrity process. That means they have limited access to the registry. They have limited write access to the file system, and they can only run executable which have the same privileges, meaning low privilege. So if they try to run a higher privilege application, the prompt is shown to the user to allow this executable to run. But there are a few shortcomings to the protected mode. So first, you can actually add what's called elevation policy to your registry. So you can actually allow Internet Explorer to run some executables. I mean, any executable with a higher integrity without having any prompt. You just need to write add a couple of entries in your registry. And while you have limited access to the file system, limited write access to the file system, you actually have unlimited read access to the whole file system. That means, again, the extension can read any file and upload it anywhere. In Windows 8, they actually introduced something called enhanced protected mode that have a more granular read access. But unfortunately, it's disabled by default in Internet Explorer 10 because most of the plugins like Flash wouldn't work with this limitation. So also there are a few changes in Internet Explorer 10 as far as security. Extensions still have a complete read access to the entire file system. Okay, so now how you install, yeah? I tested on Windows 9. Sorry, Internet Explorer 9.
Oh, Internet Explorer 9.
Yeah. So protected mode started with Internet Explorer 7 on Windows Vista. So I mentioned that both extensions are not handled directly by Internet Explorer. You actually, once you download the DLL on your local hard drive, you then have to register it so that Internet Explorer can pick it up when it restarts. When you register, meaning you add entries in the registry, you need to have administrator, right? So you get a pop-up. To package a browser extension, you have to create an installer that will do the registration for yourself, for the user. So you just have to download and run, and the executable will do the registration. But that means for the user quite a few steps. It has to download the executable, it has to run it, it has to accept the USC prompt to get administrator privileges for the registration. And it doesn't look like a small piece of software now. You're actually downloading and running an executable. But unfortunately, there are ways around that. So I don't know if any of you have tried to install the Google Chrome frame for Internet Explorer. You should try that, even if you remove after a while. That's actually very impressive and very scary. So you go to their website with Internet Explorer, you click on the link, you get no prompt for Internet Explorer, nothing. You just get redirected to a new web page where Google tells you, we've installed Google Chrome frame on your computer, you just have to restart Internet Explorer. And it's not like the extension is not doing much. I mean, it's changing switching the rendering engine from Internet Explorer and Google Chrome. So there is a way to install both extensions without prompting the user. And for that, they use two things. One is called click once deployment to deploy application more easily, and I'll go into details. And the other one is browser BHO injection. So instead of registering the BHO with in the registry with Internet Explorer, which requires administrator right, they actually inject it directly into Internet Explorer, and I'm going to explain what it is. So click once, what is it? So like his name says, it's click once for the user, or even click never click in some cases. So the way it works is you once you have your executable, your installer, you sign it, and it's probably something that was designed for intranet, because if you have the code certificate in your local store that was used to sign the executable, there's actually no prompt. So the idea was a corporate might distribute their code signing certificate to all the computers. User would just have to click on their intranet to download the software, and everything will be done automatically. They wouldn't have to worry about anything. So once you have your click once, once you have your click once package, so what will you put in your click once deployment? So the click once, if you want to extract the browser extension into a low integrity folder, so that you don't have to prompt the user again for any additional privileges. Register as a Windows service. I didn't realize that anybody could do that without special privileges. And then detect when Internet Explorer is open. So when you detect the IE Explorer process, then you inject the DLL into the process, and then you can just add the BHO directly into the process. And if you look at the source code from Chrome, it's actually very trivial to do that. It's just a few lines of C++ to do that. Then you have to sign your executable for click once and create the click once deployment package with. You can do it with Visual Studio. It's pretty easy. And here you are. Then you get BHO installed without admin access. So here's what you get when the code signing certificate is not in your local store. So you still get one click to do, but I think it's much better than the regular pop-up that you may see from your web browser that asks you to install something. So first of all, the pop-up is nothing like you've ever seen in Internet Explorer. It just looks completely different. If you minimize a web browser, the pop-up won't be minimized at all. So it really looks like an official pop-up from the OS rather than just from the web browser. And then if you click install, you don't have a way to cancel at any time. You click install, and the BHO is already installed automatically on your web browser. You don't have a way to cancel at any time. If you look carefully at the image, you might find a couple of things that look strange. And the image was not photoshopped. So how can you abuse click once? So you see three information. One is the name of the software that they're supposed to be downloading, where it comes from, the host domain, and the publisher of the code signing certificate. So the name, you can do anything, right? So I just say, okay, you're actually downloading a Windows update. That looks legitimate. And again, because the pop-up does not look like anything you've seen in Internet Explorer, it makes sense that you will be downloading a Windows update like that. And if you look at the host name, it looks like it's just coming from a weird subdomain of Microsoft.com. And that's because even though the most important part of the domain is on the right, it's a top domain of the TLD, they actually truncate the right side of the domain. So I just use some very long domain name .microsoft.com .mywebsite.com, and because it's too long, it just doesn't show up here. So if you see here hover over the string, if you do hover, you will see the full name. But that still amazes me that in 2012 we still have this kind of error where we're actually hiding the most important part of the information. So it's pretty easy to fool the user into thinking that they are downloading an official Windows update, for example, but could be any other update from an official Microsoft. Obviously, you might try to spend more time finding a better long subdomain. And there are also a couple of advantages of using this method. So first, when you inject the browser extension, it's enabled by default. And the user can always go into its options later on and then disable it. But for Internet Explorer, a new extension means a new GUID. So what you can do is every time you detect a new IX process, you just inject the same DLL with a different GUID that you know, random GUID, and then again it will be enabled by default. So yeah, if you keep disabling, then you might go to your add-on and see 50 of them. But by default, Internet Explorer does not show you the add-ons that were disabled. You actually have to go a couple of extra steps to see all the add-ons that were installed at some point and disabled. So there are actually ways around the long process of installing browser extension in Internet Explorer. Okay, quick conclusion. So browser extension are actually much more powerful than you may think. Again, full access, at least for reading your file system, and they should be really treated as complete executables and scan as well. I think that's a much better way for malware. So first of all, it's easy to code. You just have to learn JavaScript. Even for Internet Explorer, which is in C++, or .NET, you can actually use one of the free frameworks that allows you to write JavaScript code that will work on Firefox, Chrome, and in Explorer. There were actually at least 2 malwares this year, 2 rogue browser extensions that were using one of these framework, and then that means they work on all the browsers, they work on all the platform, and they really have access to everything that you may want to steal on somebody's computer. So what do you do to protect your user? So do what Chrome is doing, allow only extension from the official extension store. So Firefox, for example, they do a manual review of all the add-ons that are sent to the store before it's reviewed. It takes quite a while, especially the first time you submit an add-on, but they are thoroughly reviewed. Chrome, they are doing some automatic check, but not a human check for sure, because they just approve things too fast. And if you want to enforce this automatically, the good news is that all these add-ons rely completely on the MIME type to figure out if something is an extension. So if Firefox or Chrome if you don't know the .xpi file that's not sent with the right MIME type, Firefox will just download it as a regular file. It won't try to install it. Same thing for Chrome. If it doesn't have the right MIME type, it won't. It will just download it as a regular file. And for Internet Explorer, again, you need a special MIME type for click one that you really shouldn't be using on Internet, except for the Google Chrome store. Internet Explorer does not have a real extension store like Firefox and Chrome. So if you want to let your user use extension for IE, you probably want to vet the extension before they are downloaded and host them on your intranet and only allow extension from there. Or you could just completely disable extension installation by locking down Windows. Or the web browser have settings that the administrator can set to disable the installation of any extension. Yeah, and that's it. Any question? Yes?
Did you agree with the statement that another mitigation could be that these browsers expose APIs for antivirus to scan extensions either while they're being downloaded or before they're loaded into the browser?
Okay, so they have asked me to repeat. So the question is, should web browser expose the extension to the AV before it's actually executed? That would be nice if AV vendor were actually catching them. I mean, every time I uploaded one of them, the success rate was very low for JavaScript extension. So yeah, I think that would be better. So you don't circumvent the AV scan that happened with the download manager. But until they do a better job, that's probably not going to help too much. Yeah.
Does Microsoft know about the click once problem?
I don't know. I didn't ask.
The definition of know about the problem. They certainly know that it's there. They wrote it and use it internally. Do they know that it's that easy to sneak things past people?
Yeah. I think it's probably something that was designed for intranet, but
Probably told them.
Yeah, it really looks something that was designed for Ethernet, where there's a lot more trust. Especially again, if you push your co-signing certificate, then there's no click, and shouldn't be exposed on the.
But it still works on the internet.
Yes. Yeah.
We've got much of people around here, including myself. So if you want to have a call with them or whatever, you cannot.
Sure.
Also in IE10 you have something called app container. I'm not sure.
Yeah, so that's what. Yeah, but so that's what that's what I explained with the enhanced protected mode, right? That's the same idea of granular read access, and you don't have access to whole file system, a part of it. But I haven't installed Windows 8. But from what I saw from the official blog is that because plugins like Flash wouldn't work with that because they expect to have full access to the file system. It's actually disabled by default in IE10.
Let's have a talk about that.
Okay, sure.
It's not exactly correct, but let's talk about it.
So otherwise, this year I've actually seen a lot more malicious rogue extension. I've seen it in the news and I've seen it in my research also. There's a lot of web pages, for example, that claim that you don't have a right fake Flash, the right Flash version, and you need to download one. And until this year, it was always an executable that you have to download. And this year, I think twice, it was actually a browser extension that they wanted you to install, and not an executable. And the detection rate for so that's 3 versions: one for Chrome, one for Firefox, one for IE. The detection rate was actually pretty good, and for Firefox and Chrome, it was very bad. There was one cross-platform and cross-browser version that was for sale. I think was it beginning of the year or end of last year? I don't have the name, but it was a rogue extension for sale. So it's not yet. I don't think it's that widely used, but there is an increase, and I think it makes sense. Rather than having this fake AV update that looks really fake, I think something like click once is much more effective. Do we have time or not? Okay, there's nobody. Are you interested in maybe just add a couple of demos ready? I can maybe just show you how easy it is to add a third-party extension without getting any warning, if you're interested. If you want to leave, I know you might be hungry. I don't mind. If you want to look at this. So I created just a profile, Firefox profile just for source, because I didn't want to mess up with mine while I was testing. Okay, so it's under app data, roaming, Mozilla, Firefox. Let me run. Okay, and that's good. So I actually tried this Illivid player that I was showing a screenshot, and I did a custom installation where I said I don't want the AS toolbar, and here it is. Actually, it actually installed it on all my profiles, but because they didn't go the extra mile and change the database, I'm actually prompted. So I'm going to say no, I don't want to use it. So you see add-ons. I need to remove this one. This was what we're looking for. Okay, so this is what I have. So here, quick demo. So you will add this type of stuff to your executable, obviously without a window that shows what you're doing. So you can look for the profile at a known location under your user directory. Then you can enumerate all the different profiles. So I was only interested in this one. I'm going to, so I'm running from here, and I'm just going to copy this folder, which contains the browser extension, into my source extension. So that's what the application was doing. Okay, then look at the extension database. That's again, no, non-location doesn't change. Okay, so now I'm done. I can just show you quickly the code. No, where is it? Okay, maybe I'll show you later. Now if you look under my profile and source profile, you will see an extension, this 7.5 stuff that I show you is here. And so remember, for the two last bars, I did the same thing, but they didn't change the database. So now if I run, and if it doesn't work, it will look like a fool, but let's try. Right, nothing, no new plugin. But if you actually look under add-ons, you see here, again, just find a name so people don't actually remove it. That's the add-on that I installed. And if you, I did something very simple. So if you look at everything, again, you can say, okay, what's the home page? It's Mozilla. Who created it? It's Mozilla. So it looks like an official plugin. Hopefully, do not remove it. People will read it. And what it's doing is just what I do for this one. Whenever I browse, I can maybe. Whenever I browse, it just send the URL to my server, so I know what the user is doing. It's also looking for the first three login and password that the user saved and send it to a server. So it's very easy, completely silent, and Firefox doesn't have any protection for that. And the strength and the force of Firefox is that they're very open, so anybody can hack, look into the database, but you can do it for good to learn how Firefox works, and you can do it for bad. I was trying to do the same thing with Chrome, figure out where they store the information for the database, but for the extension to see if I could insert mine, but it was much harder, and didn't have time to. I didn't find out where it is. Probably should spend more time. Okay, thanks.